Here's the answer key summary for the electricity. First we have Ohm's law, which remember is voltage equals current times resistance. V stands for voltage, I stands for current, R stands for resistance. So these are the units we have for that is volts, amps, and ohms. For the power equations, remember I've seen a few of you already, like this isn't talking about mechanical power, we're talking about electrical power. So that is current times voltage, or there were two other ways to write it. It was current squared times resistance, or voltage squared divided by resistance. So P stands for power, which is pretty much just your energy per time, measured in watts. I stands for current, which again is the flow of electricity or electrons, and that's measured in amps, like above. And then we'll say V stands for voltage, which is what, so basically voltage is what the force or the like push to make the electrons flow. And that is measured in volts, or we label that as V. Devices in a circuit. So battery is what provides the voltage or push. Make electrons flow. Now, if you remember, the electrons are already in the wires or the conductors, but basically they just need some kind of battery or potential difference to kind of initiate the electrons flowing in the circuit. Resistor is like the light bulb or any electrical appliance that requires energy to work, and so these basically the resistor opposes the flow and it'll convert some voltage or power into mechanical energy, heat, etc. The wire is basically the conductor, and it gives a surface for electrons to flow easily. Fuse, what does the fuse do? The fuse monitors the amount of current in the circuit so we don't blow something up. Voltmeter, it measures volts. Amp meter measures amps in the circuit. So basically an amp meter, we just need one little thing to put in the circuit to figure out how many how much current is flowing through that area per time. Remember, because amps is basically electrons per or charges per time, which is measured in coulombs per time. So series circuit, basically if we pull up, I'm just going to go ahead and pull up the PhET simulation. So a series circuit has a battery, wire, and the light bulbs are connected one after the other like this. So if you notice in a series, there's only one loop or one circle. So what happens if we disconnect one of the light bulbs, the other one goes out. So they both have to be connected in order for it to flow. We know that if there's one loop, there's only one current. And for voltage, we know that the voltage divides up between the two light bulbs or resistor. And lastly is a parallel circuit. So what changes here now is if we disconnect this, you notice light. So basically we have two loops that are both connected to both sides of the battery. So basically the light bulbs look brighter now. So if I go ahead and, so we have multiple loops in a parallel circuit. So if we take one out, the other light bulb will still stay lit. Now we know that the current divides and now we know now what happens is the voltage stays the same. So that is to help you guys review for electricity. You can email me if you have any other questions, but otherwise hopefully this helps you guys study.